My name is Greg Ford, and this is a Network Support Management semester project. For this project, we're going to start with an overview of each network, and then we'll break down the tasks required for each network and how we'll solve them. The first step is, of course, the overview. For this, we're using 3 different routers. The first router is a Cisco 1941 series, and it has a maximum speed of 1 gigabyte per second. The second router being used is the 1841 series, and it has a maximum speed of 100 megabytes per second. Now the third router being used is our gateway router, which has a maximum speed of 1 gigabyte per second, and it also has some wide area network switches which allow for a lot of security features for data coming into and out of the network. We're also using 2 different types of switches. As indicated, we have the 100 megabyte per second 24 port switch, and we have the 1000 megabyte per second 24 port switch. Now looking at the overview, you can see that one of the issues is that we have 1000 megabyte switches running to a router that has a maximum speed of 100 megabytes per second. We'll revisit this later, but while the picture is larger, it's a good idea to look at this and get an idea of what we're actually seeing. Now here we're going to go over our tasks. The intent is to speed up the network to allow for 1 gigabyte per second speeds for all hosts on the network. The second task will be to upgrade the IP addressing to IP version 6 while still staying compatible with IP version 6 IP addresses. We must also leave room for at least 25% growth in the network. The first step is going to be to identify the problems within the network and then to propose the solutions. In this case, on all images you've seen, I've already put the IP version 6 information in here because the IP version 4 did not allow enough room for the 25% upgrade growth. And so I already did the work, so I just put that image in there from the get-go. It wasn't hard. It's IP version 6. Or I completely misunderstood it. The first issue with upgrading to 1 gigabyte per second speeds will be the hardware being unused. Now in this case, as I previously mentioned, we have 1000 megabyte per second switches connected to 100 megabyte per second routers. And of course vice versa. This means that when these 2 devices communicate, they're going to communicate at the speed of the slowest device. So therefore the slower device is effectively limiting the speed of any device it's connected to. Now some of this hardware is also not capable of reaching the desired speed. So there's no amount of configuration you can do that will actually speed up that portion of the network. In this case, the limiting devices we have are the Cisco 1841 routers that are maxed out at a speed of 100 megabytes per second, and of course the 100 megabyte per second switches that also have a speed of 100 megabytes per second. Issue number 2 is upgrading to IP version 6. We visited this a little bit previously, and in this case, as I said, I've already divided the network into IP version 6 subnets. The IP version 4 did not have enough to account for the growth that we were wanting to account for. So in this case, IP version 6 would be the only way you would be able to account for that growth, for a 25% growth in the network. The IP version 4 network is not shown, which probably would have been helpful. Now the solution to the speed issue. The first solution to correct the communication speeds on the network is going to be, as mentioned, to upgrade the equipment. The 1841 routers, which I for some reason wrote 141 routers, and the 100 megabyte per second switches are not able to reach the desired speed. So these routers and these switches will have to be removed from the network. The proposed router to replace the 1841 router will be the 1941 router. This is going to allow for all the devices to communicate at the fastest capable speed, which just so happens to be the minimum speed that we're wanting to put in the network. This will also eliminate the need to upgrade all devices. That means that the existing 1941 routers and the 2900 router can stay in the network without having to be upgraded. Now the switches will have to be replaced with 1000 megabyte per second switches, which are currently in use in some places. And then we just take the 100 megabyte per second switches and replace them over. This again saves us from having to replace all of them, and it allows them all to communicate at the desired speed. Now IP version 6, the best way to upgrade this is to make sure your iOS software is up to date. Currently, the latest version of iOS software is compatible with IP version 4 and IP version 6. However, the IP version 6 will not be working on any ports unless you go through and enable it on all of the routers. So in this case, you would have to go through, put in the command to enable it to make sure that it is compatible with both. The West Coast network. This network is a lot smaller than the East Coast network, but the demands are still the same. This one uses fewer routers and switches, but they still use the same type, except this one does not have the 2900 gateway router that we had on the previous network. And as indicated, all of the specs for these particular routers are going to stay the same, so that makes things a lot easier. And the tasks are, of course, the same as the last one. Speeds will need to be upgraded and will need to be capable of IPv6 and IPv4 addressing. So the first step, upgrading to 1 GB per second speeds. Of course, the issues on this side are exactly the same as the last, except this one looks a lot worse. As you can see at the very top, we have our 1000 megabyte per second switches connected to our 100 megabyte per second routers, and that actually occurs on the top of the screen and at the bottom of the screen. And then the 3 in the middle, we have 100 megabyte per second switches connected to 100 megabyte per second routers. So in this case, they're communicating at their maximum speed, but their maximum speed is still lower than it needs to be for the requirements. So basically, in this position, we've got our faster routers being slowed down by our slower switches, and our faster switches being slowed down by our slower routers. And then, of course, the slower routers and slower switches are not capable of the maximum speed that we need. Issue number 2 is upgrading to IP version 6. Just like with the last network, I've already divided the subnets into larger portions of the network than needed. And in both cases, you'll notice that the subnets that I provided are massive. This allows for much larger than 25% as originally requested. In this case, I am fully abusing the space that IP version 6 allows. It just makes it simpler and you get more room, and because we're using unique local unicast addresses, we don't really have to worry about the overlap. And of course, I should have broken down the local unicast addressing previously. So in this case, I'm going to take the opportunity to do that right now. Your first 2 hex digits are going to be the digits FD. Then it will use a 40-bit global ID. In this case, I chose the simplest global ID possible. 0001, 0002, and then the last 16 bits were to identify that individual subnet. And which is exactly your next step. The first 2 parts will actually make the prefix, and then the last 16 bits will be to identify the subnet. In this case, as I said, I chose the simplest one, and you'll notice on the other one it is FD0011, and then the subnet, whereas on this side I chose FD0012, and then the subnet. And of course, if you add up all the bits used, you will find that this is 64 bits and 48 for the entire network. Now the solution to issue number 1, of course, same as the last time. It's much simpler to upgrade the equipment and to switch around equipment in some places. In this case, since we need to get the speed up on all parts of the network, we're just going to be upgrading the equipment. This will take your 1841 modem and your 100 megabyte per second switches, and we're going to remove those and replace them with a 1941 modem and a 1000 megabyte per second switch. This will allow us to communicate at the faster speeds across the entire network, and of course will allow us to kind of simplify a few parts of the network that don't need to be upgraded, move things around. It prevents us from moving things really. The first step here, how we're doing our IP version 6 addressing. I think I went into more detail on the introduction to the issue than I'm going to on the solution, but of course the solution remains the same as the introduction I gave previously and as well as the last issue. The software on all devices has to be up to date in order to be compatible with IP version 6 as well as IP version 4, and IPv6 will need to be enabled using a command on the iOS software. This will guarantee that they can use the new IPv6 addresses that are being shown as well as the IP version 4. If the software is not up to date, you may have issues with actually making it compatible with the IP version 6. And of course, here are the references used. You'll notice most of them, if not all, are on the Cisco website because I did a lot of research on the devices being used. Thank you.